Okay, so here are a few pedigrees that we're going to practice with in trying to figure out the modes of inheritance. Now, so for all of these, we can just use the premise that these are inherited diseases. And when we talk about pedigrees and what they show, they're showing like the inheritance of certain traits. And if you have a shaded in individual, that means whatever trait you are talking about, that individual expresses or has that phenotype. So oftentimes our struggle with pedigrees is to figure out the mode of inheritance. Is the trait inherited autosomal recessive? Is it autosomal dominant? Is it sex-linked recessive? Which a lot of times sex-linked is implying on the X chromosome. Or is it sex-linked dominant? Right? That's the question we are trying to answer when reading pedigrees. So, I like to start with whether it's dominant or recessive first, and then from there try to figure out if it's sex-linked or autosomal. Now let's go ahead and start by looking for certain clues within our pedigree where we can do process of elimination to figure out. So one thing I see here is this individual number 17 has the trait while neither parent does. So now this is my job to think about, well, what kind of inheritance could produce this? If I say, okay, well, I'm thinking that it could be a recessive trait, and now to model that or mimic that, I could assign each parent a genotype, and I could say, okay, well, if the trait is recessive, that means that the individual would have to be homozygous recessive to have this trait. And so could two parents who do not have the trait produce this combination? Yes, if both parents were heterozygotes, they would not have the recessive phenotype. They would have the dominant phenotype, but they could make a child with the recessive phenotype. So now I'm like, okay, well, autosomal recessive is likely. Now, could this be autosomal dominant, though? And so then you would say, if it was autosomal dominant, number 17 would have to have at least one copy of a dominant allele. But then you would say, well, like for a parent then, if it was autosomal dominant, right now neither parent has this phenotype. So therefore, both parents would be recessive, and they don't have a dominant B to give this child. So therefore, we know that this is a recessive inherited trait. But then the question becomes, is it a sex-linked recessive? Well, if it was sex-linked recessive, then this female, in order for her to have this trait, she would have to be homozygous for it. And that means she got like this one from her mom and this from her dad. But remember, a dad or a male has only one X. So therefore, if he gave an X to the daughter that was recessive, well then he would also be shaded in, and that is not the case. So therefore, we can eliminate sex-linked as a possibility, and we know with certainty that this trait is inherited as autosomal recessive. Now you can also double check, so we can take this situation here, and if you're like, okay, anyone who has the trait is autosomal recessive, well, then that would make sense. And up here, we know that number 2 has at least one dominant allele. We look at their offspring, and all of the offspring are dominant, so they've all inherited at least one. Well, maybe this parent then is homozygous dominant, but all of the offspring are heterozygous because of this dad. So, okay, now let's go ahead to another pedigree. So in this one, we're going to look for any clues first that we see. And the first thing I notice is that out of this parent's offspring, they have one with the trait, one without the trait, with the trait, without, with. So it's about a 50-50 inheritance. I also notice that that's really all the clues I see here, that when you have two parents without it, none of their kids do. Okay, so now you can just start the process of elimination. So let's pretend I'm curious if it's sex-linked, because I kind of see like there's males, but also there's about an even number of females. So let's see if it's possible for it to be sex-linked recessive. So if it's sex-linked recessive, then that would mean that this male has the trait, and this female has at least one X, at least one dominant, maybe two. It just depends. So if it was sex-linked recessive, then this female, she would have to inherit 2 copies. Is that possible? Sure. We don't know what this mom's second X is. Over here, let's use this female. If it was sex-linked recessive, then she would have to have 2 X's like this, 2 recessive alleles. Well, now when her gametes are produced and her X's separate, her sons would all inherit the recessive allele. And what we see here is this son does not have the trait, so therefore we can eliminate sex-linked recessive as an option. And so now if you're like, well, what if it's sex-linked dominant? Well, because this daughter number 6 gets an X from the mom and the dad, if it was sex-linked dominant, well, that means that this daughter would also have it, and she doesn't. So right now for this pedigree, we can eliminate sex-linked as a possibility. So now we're down to autosomal and whether or not it's dominant or recessive. So now I'm going to just use a different color. Maybe you can see it. Let's see. So if it's autosomal, now this is where you can kind of just plug in different alleles. And let's pretend it's autosomal recessive. And so you assign, well, you can't really see that, but you assign little b. And then here, if you're like, well, I'm not really sure what the next allele is, because you only have to have 1 copy to have a dominant phenotype. And if I'm saying this is a recessive phenotype, then this individual child would have to have 2 copies. If it gets 1 from the dad, it would have to get 1 from the mom. So then we would know that the mom is heterozygous in this situation. And so here, could this couple make this combination of offspring? Sure, this one could inherit the dominant from the mom, the recessive from the dad, then a homozygous recessive. So this is totally possible so far. And then we look down here at these offspring. So to get a 50-50 or a 1-to-1 ratio, you could easily have a heterozygote crossed with a homozygous recessive. That would work. Now here you have a dominant phenotype. You could have another dominant phenotype. Well, the fact that all 3 inherited 1 dominant allele at least, maybe this wife was homozygous dominant, that's possible. And over here to get a 1-to-1 ratio, could be a heterozygote. So as of right now, you could very easily say that this trait could be inherited autosomal recessive. Well, could it be autosomal dominant? Sure, let's see. So then here with this, if you assign a dominant allele like this, and then say that the mom is homozygous recessive, well then all of these children would have inherited a dominant allele. Okay. So at this point, you could say that all of the ones that are not shaded in are homozygous recessive. And again, this also works. So here, you get a 1-to-1 ratio if this is a heterozygous, etc. So at this point, we don't know if this trait is inherited autosomal dominant or autosomal recessive, but we definitely eliminated sex-linked as a possibility. Okay, let's go on to another one. So here in this one, we're going to go ahead and look at for clues. Right away, I see this and I see this. So for a trait to show up in offspring and it not be in the parents, that trait has to be recessive. And at this point, we would need to ask ourselves, is it autosomal recessive or is it sex-linked recessive? So if we look at this and we just assign values to see could it be sex-linked, here, if we say it's sex-linked recessive, it would make sense that both sons inherited the trait, but not this daughter. And then this daughter could be like this. She would have to be heterozygous because she got 1 X from her, 1 X from her mom, and then the dominant X from the dad. And then she has 2 sons, so as her X's separate into different gametes, this would also be possible. and then this daughter has at least one dominant X from the father. So in reality, could this be sex-linked recessive trait? Sure. But could it also be just plain old autosomal recessive? Like, could this just be brown eyes? I'm sorry, blue eyes? Let's see. If we assigned like this, a little b, and then number 1 is heterozygous, we see that there are 2 children, so with the trait, so that means the dad would be heterozygous. And if this blue-eyed person married another blue-eyed person, then all their kids would be blue-eyed. Now over here, is it possible for these 2 parents to have a child without blue eyes? Of course. And then could they have married a heterozygote? Of course. So at this point, we just know the trait is recessive, but we don't know for certain if it is sex-linked or if it is autosomal. So it could be either one, but we do know it is recessive. Let's go ahead and look at this one. So here what we see is, let's go ahead and think about one major clue is that when we look at this trait, we notice that it is a male with 2 daughters that have this trait and neither son. So if we were to like hypothesize that this trait was sex-linked dominant, that would make sense because each daughter is going to inherit a dominant X from the father, and then this mother then would have to be homozygous recessive, which also makes sense because now each son does not have this trait. Now if you think, well, does this still hold true up top? Well, if the father does not have the trait and the mother does, we know she has at least one dominant X, and both, like out of her children, her X's separate into gametes, and if she was heterozygous, these 2 could have been inherited her lowercase r, and then these 2 could have inherited her dominant r. And so, to me, this trait is seeming pretty obvious that it's going to be a sex-linked dominant trait. Now, could it also be an autosomal trait? I think so. However, the fact that it has just males and not daughters and not sons coming from the dad is a clue that it's probably going to be sex-linked dominant. All right, let's go ahead and look at this one. So up here, this is actually, if we look at 2 parents having the trait but not the child, ooh. So the only way that can happen is because if this was both recessive, then all their kids would have it. But because they have a child without it, we know it's a dominant trait. And so with this here, this trait is going to be inherited as an autosomal, as an autosomal dominant. Oh, the reason why, sorry, I was like questioning myself for a minute. Because if it was a sex-linked dominant, then, if it was a sex-linked dominant, the dad absolutely gives one of the daughters his X's, and since the daughter's the one without the trait, we can eliminate sex-linked as a possibility, and this is just an example of an autosomal dominant trait. Okay? Let's go ahead and look at this one. So right here, right away, the fact that there's only males with this trait implies that it's going to be sex-linked, and the fact that it is not in the parents is a sex-linked recessive. But one thing that I noticed in students' answers is they say things like all males need to have it. That is false, because if a female doesn't have a trait, only half of her eggs will carry this recessive allele. The other half of her eggs won't. So it's not all sons, it's just some of the sons will inherit this recessive X. Okay, let's go ahead and look at this example here. Sorry, I had to hit pause and erase and start over this pedigree here. So when we look at this one, what we notice, if we're trying to think about how this one is inherited. So I see some males here and with the mothers. So now I'm going to think, okay, maybe it's sex-linked. I'm going to go ahead and start with that as my possibility. And then I'll move into seeing if it's autosomal. So if I think to myself, well, maybe it is sex-linked recessive. So if it's sex-linked recessive, then that means that the daughter here, number 5, if it was a sex-linked recessive trait, she would have to have 2 copies of the recessive allele. If she got one from her mom, that would work, if the mom was like this. But then she'd have to get a second one from her dad. And because the dad is not shaded in, we know that it is not sex-linked recessive. So then you might ask yourself, okay, is it sex-linked dominant? So here, if it's sex-linked dominant, that means the mom has at least 1 copy of this. At this point, we're not really sure of her second copy. The dad would have to be sex-linked recessive to not have this trait. But we see this daughter here without it. So if the trait was sex-linked dominant, that means if they have the dominant X, they express it. So right here, this daughter would have inherited 1 dominant, and then from the dad, a second. Well, then this daughter would have to have 2 copies of not having the trait, so therefore the mom would be heterozygous. But then when we go down, if we say that this trait is going to be sex-linked dominant, we would think to ourselves, okay, is that possible for this trait to be sex-linked dominant? And what we find is here, this son, number 4, he would have to have the trait, have at least 1 dominant X, and you have to think to yourself, where did he get his X from? He would have had to get it from his mom. But the mom does not have this trait, so we know sex-linked dominant and sex-linked recessive are eliminated as possibilities. So then we get down to, is this trait autosomal dominant or is it autosomal recessive? But from what we're given here, there's not really enough information to say with certainty, because this could be a blue-eyed person and a brown-eyed person that have a blue-eyed and brown-eyed kid. Or it could be vice versa, like a brown-eyed person and a blue-eyed person having a 1-to-1 ratio. So here you're basically having 2 heterozygous parents, 2 parents that have different phenotypes, and like both of these outcomes are possible. So we can't say for certainty if this trait is dominant or recessive, but we do know that it is autosomal. Okay, so now here's our last little group of pedigrees to kind of look at. In this one, you're going to think to yourself, okay, that this is going to be a recessive trait because it shows up in an offspring and not the parent. Now, what is missing from this is that they don't have what the other parent is. Now, with just this information, you might be thinking to yourself, is this sex-linked or recessive? Or autosomal? I don't know. There's not quite enough information to say, but if it's on an X, you might think it's sex-linked, but then again, we don't know what the father was to make this offspring, and there's just not enough to say for sure. Now, over here, though, you think to yourself, okay, the mom has the trait, and both her sons do, but neither daughter. This, to me, implies that the trait is going to be sex-linked recessive. So if this trait was sex-linked recessive, then both her sons would inherit it, and the dad would be dominant, and then both his daughters would be fine. So that is the clue that I'm looking for in this one. And then down here, I can see how the 2 offspring don't have it. So this daughter was able to pass on, this dad is sex-linked dominant, right? There's a 50-50 shot that the kids will inherit that, and they're fine. Now over here, if you're like, well, if the dad has it, how come his daughter doesn't? Well, even if the daughter inherited this dad's recessive X, she could have very easily inherited a dominant one from her mother. Okay, let's go ahead and look here. Now with this pedigree, the fact that all 4 children have this trait from parents that have different phenotypes, I'm going to say that this trait is is a dominantly inherited trait, and therefore all of these children are heterozygous. Now, We don't know what the other parent is here, but if this was a heterozygous individual, well, then they could have crossed with like a blue-eyed, and then both their kids have blue eyes. Like, that's possible. So we know that this trait is a dominant trait as well. Oh, actually, we don't know because we don't know that other parent. But anyway, that's what I would interpret when you have all of them having a trait when one parent doesn't, is that now, okay, if this parent was shaded in, then you could say, well, maybe it's recessive, but the fact that this parent is not shaded in, just one is, I'm thinking it's autosomal dominant. Now, over here, with this one, we look at every pairing. Like here you have one parent with the trait, one parent without, and you get a 1-to-1 ratio. That tells me that the cross is going to be this. Now, which trait is dominant, which trait is recessive? I'm not sure because I don't know who these people mated with. Because we see their offspring are also in a 1-to-1 ratio, and therefore I'm not really sure which one is dominant or recessive. All right. Good job, guys.